Hello everyone, welcome to day number 13 of this challenge or of this series. So today we're doing one question and it is this question. Alright, so let's get straight into it. So number 5. An athlete competing in long jump leaves the ground with a velocity of 5.6 meters per second, alright, at an angle of 30 degrees to the horizontal, alright, okay. Determine the vertical component of the velocity and use this value to find the time between leaving the ground and landing. Okay, so let's actually draw a vector diagram for this, right? Okay, let's draw a vector diagram for this. Let me change the color. So, an athlete leaves the ground at a velocity of 5.6 meters per second. Alright, and it has an angle of 30 degrees to the horizontal line. Alright, so this is the vector we're dealing with. Second, let me write it again. Alright, so actually it's 5.6, right? Give a second. Alright, so I have to determine the vertical component. So I have to determine this, right? So we just use simple trigonometry with this one, okay? So this, see, we can use sine 30 equals to opposite length, which is the length we want to find. Let's say that it is x over the hypotenuse, right? So it's 5.6. So to get x, we just do this. We just multiply 5.6 with sine 30. So I will use a calculator for this one. Let me change it to degree mode. And 5.6 multiplied by sine 30. And this will get 2.8 meters per second going upwards. So the vertical component of the velocity is 2.8 meters per second. And you have to use this value to find the time between leaving the ground and landing. So let's think of it like this, right? So here is the ground and the person is gonna jump like this. Yes. So this is a vector that we're gonna see, and this is a vector. The vertical vector is gonna be 2.8. And let's see the displacement of the vector. So the vertical component of this person is going up, and it stopped at this point, which is the maximum point of this person's trajectory, and then it goes back down, and the displacement is 0, right? So like the person vertical vector is right here at start, and then it goes up, and then it goes back down again, right? So the displacement is going to be 0. So importantly, for the vertical vector, the displacement is going to be 0. The displacement is going to be 0. So we can use the formula as equals to ut plus 1 over 2 at squared. So we know the s, we know the u, which is the inertial velocity, which is 2.8 meters per second. This is meters. Now we want to know the time, and then the only data we don't know is acceleration, but we can find acceleration. The person is being active by gravity, right? So there's always going to be gravity force going downwards. So the gravity force is 9.8 meters per second. Meter per second square, meter per second square, and it is facing downwards, so it's going to be negative 9.8. So right, so the acceleration is going to be negative 9.8 meter per second square. So now we just put that in here. We'll work out a quadratic equation. So 2.8t plus actually is minus 9.8 over 2 t squared. So I just use the calculator to solve the quadratic equation. So negative 9.8 over 2, 2.8, 0, you'll get t equals to 4 over 7, and then t equals to 0. Alright, so you'll notice that we get two t values. This is because the displacement is 0 in two positions, the start and the end. So this tells us that this t equals to 4 by 7 is this point. That means that the person will jump and reach the ground at exactly 4 over 7 seconds. So we can change that into decimals. So 4 over 7, they'll get 0.57. So this is this is 0.57 seconds. Okay, so let's move on to number D. Determine the horizontal component of velocity and use this value to find the horizontal distance traveled. Alright, bet. So let's do that. Okay? So, the horizontal component, so we just use normal trigonometry to solve this. So, we're finding this length. Let's say, let this length be y. So this time we use cosine 30 equals to 1, which is the adjacent length, and the hypotenuse, which is 5.6. So y equals to 5.6 cosine 30, and now use the calculator. Otherwise, this cosine 30, that will get 4 point. Should I write it in exact value? 14 root 3 over 5. Okay, so the y value is 14 root 3 over 5 meters per second. So we're finding the distance here. We know the time. We know the velocity. So we just use the normal speed. Distance equals speed times multiplied by time. So the distance will be speed, which is this. And the speed times multiplied by time, which is 4 over 7. That's that 4 over 7. And this will get the total distance. So it'll be 14 root 7. Root 3 over 5 multiplied by 4 over 7. That's again 8 root 3 over 5, or about 2.77 meters, 2.77 meters for it to reach, or for the person to land and how far the person will go. So yeah, guys. So this will be the answers to this question. This t will be 4 over 7 seconds, and distance equal to 2.77 meters. So we'll see you again tomorrow. And so yeah, goodbye. And goodbye. I'll talk to you guys later. Goodbye.